So, thank you. Good morning. And thank you for coming to my talk. So, there's a popular Japanese proverb adapted from a Chinese fable, whose English translation goes something like this: a frog in a well does not know how great the ocean. So the story is that the frog lived down in a well where he had all that he could. And one day a tortoise came by and told him about the sea. The sea, said the frog. What do I need that for? I have everything I need in my well. It's paradise. And what is this proverb trying to teach us? If you're the frog, maybe you think you know all that there is to know. You know your surroundings intimately, yet you're unaware of just how small your home is compared to the whole world outside. And you don't know how limited your knowledge is. And so the lesson here is that you should question your environment and certainly question your assumptions. And don't assume that you're right just because nobody has proved you wrong. And proverbs like this are very popular in Japan. So popular that they often have a shorter form. And so one person will say to another, a frog in a well. And maybe they understand that advice. And if they do, they understand it not from just those 4 words, but because they're understanding the meaning behind those words. Now, last year, Rob Pike gave a talk at GopherFest entitled Go Proverbs, and it was inspired by the English translation of Seigu Kensaku's famous book on the game of Go. And in his talk, Rob Pike asked, are there Go Proverbs? And the answer is yes, of course there are. There are indeed Go Proverbs. And you probably recognize them. And just like the story of the frog, to understand these Go Proverbs, it's not sufficient to just memorize the words. You must understand the lesson that the Proverbs are trying to teach you. Now, I don't have time today to discuss every one on this list. Instead, I want to talk about one aspect of Go's design and relate these ideas to some of the Go Proverbs as I understand them. So, what do Go programmers mean when they say to each other, errors are just values? When we say errors are just values, what we actually mean is any value that implements the error interface is itself an error. But just saying errors are just values to someone who is still just a student of Go, it's not useful. To understand the proverb, the student must understand the underlying message that it tries to teach. And I think this is a good place to start a discussion on what I think it means to understand Go's error handling philosophy. Now, I've spent a long time thinking about the best way to handle errors in Go programs. What I really wanted was there to be one single way to do error handling, something that we could teach to all Go programmers by rote, just like we teach the mechanics of how to use a slice, or we teach the syntax of the language. Now, unfortunately, I'm pretty sure that there is no one single way to do error handling. But at the same time, I don't believe it's an infinite field of possibility. I believe Go's error handling can be classified into 3 core strategies. The first category of error handling is what I call Sentinel errors. The name descends from the practice in computer programming of using a specific value to signify that no further processing is possible. And so too with Go, we use specific values to signify an error. Examples of this include the classic IOEOF, or low-level errors like the constants in the syscall package. And there are even Sentinel errors that signify that an error did not occur, like, for example, Go builds no-go error, and the filepath skipter error, which you use when using filepath.walk. Now, using Sentinel error values, I think, is the least flexible error handling strategy, because the caller must compare the result of a pre-declared variable and use the equality operator. This presents a problem when you want to provide more context, as returning a different error would break that check. Even something as well-meaning as using the funct errorf to add some context to the error will defeat that caller's equality check. Instead, the caller will be forced to look at the string output of the error's error method to see if it matches a specific string. And as an aside, I believe that you should never inspect the output of error.error, because it exists for humans, not for code. That content of the string belongs in a log file, or printed out on screen, or returned to the user in some way to give them an explanation. But you shouldn't try and change the behavior of your program by inspecting that error string. Now look, I know that sometimes this isn't possible. Like this is slightly aspirational to say these things. And certainly this advice does not apply as absolutely when you're writing tests. But nevertheless, comparing the string form of an error, in my opinion at least, I think it's a code smell, and you should try and design your programs to avoid needing to do this. Sentinel errors have other drawbacks. For example, if your public function or method returns a particular Sentinel value, then that value must be public, obviously, and because it's public, it should be documented, and all of this adds to the surface area of your API. And also, if your API defines an interface which is specified to return a specific Sentinel error, then all those implementations of that interface will be restricted to returning only that error, even if they had the opportunity to return something more descriptive. We can see an example of this with io.reader. Functions like io.copy require that the reader implementation, no matter what it is, returns exactly ioeof to signal to the caller that there's no error, there's just no more data. But the worst problem with Sentinel error values is that they create a dependency between two packages. So to check if an error is equal to EOF, obviously the calling code must import the IO package. This specific example doesn't sound so bad because we do this all the time. It's very common. But imagining the coupling that would exist when many packages in your project export their own set of error values, and all the other packages in your project must import them to do those checks. Now, having worked in a large project which toyed with this pattern, I can tell you from personal experience that the spectre of bad design in the form of an import loop was rarely far from our minds. So my advice to you is to avoid using Sentinel error values in the code that you write. There are a few cases where they're used in the standard library, but I think it's a pattern that you should choose to not emulate. If someone asks you to export an error value from your package, I think you should politely decline, and instead suggest an alternative method, which I'll go into next. Error types are the second form of Go error handling I want to talk about today. As the name suggests, an error type is a type that you create which implements the error interface. It's pretty straightforward. This is an example of OS path error, which is a type which tracks the underlying error that might occur in a file operation, as well as the path that you were using and the operation that you're attempting to do. Because path error is public, callers can use a type assertion to extract extra context from the error if they need to, as we see here with this switch. But error types must be made public so the caller can use that type assertion. And if your code implements an interface whose contract requires a specific error type, just like a specific Sentinel error that we talked about earlier, all the implementations need to depend on the package that defines that error type, again creating source coupling. And it's this intimate knowledge of a package's type that creates this strong coupling and makes for a brittle API. So while error types are better than error values because they can capture more context about what went wrong, error types share many of the problems of error values. So again, my advice is to avoid using error types, or at least avoid making them part of your public API. Now I want to come to the third category of error handling. And this is, in my opinion, the most flexible error handling strategy, as it requires the least coupling between your code and the caller. Now, I call this opaque error handling because while you know that an error has occurred, you don't have the ability to see inside it. As the caller, all you know is that the result of the operation either worked or it didn't. And if you adopt this position, then error handling can become significantly more useful as a debugging aid. For example, here, in bar.foo's contract, we've made no guarantees about what it will return in the context of an error. So the author of bar.foo can now annotate any error that it produces or is produced inside that method without breaking its contract with the caller. It promised very little, so it has a lot of flexibility. And this is all there really is to opaque error handling. Just return the error without assuming anything about its contents. Now, there are indeed a small number of cases that this kind of binary approach to error handling is not sufficient. That's very true. For example, interactions with the outside world, like network activity, require the caller to investigate the nature of the error and decide, is it reasonable that we retry this this operation? And in this case, rather asserting the error is a specific type or a value, we can assert that the error implements a particular behavior. So let's talk about this example. We can pass any error that we receive to our isTemporary function to determine if the operation is possible to retry. Now, if error does not implement the temporary interface, that is, it does not have a temporary method, then by definition, this error is not temporary. And if the error does implement temporary, we know a little bit more about it. And perhaps the caller can use the temporary function to decide whether this error is retriable or not. But the key here is that all of this logic can be implemented without importing the package that created this error, or indeed knowing anything about that error's underlying type. All we're interested in is its behavior. This brings me to the second Go proverb that I want to talk about. And that is, don't just check errors, handle them gracefully. So here's a question. Can anyone tell me what is wrong with this piece of code? Just shout it out. There's an obvious error, or it could be made better. Yeah, I heard it over there. You can just make this one line. Like it's too verbose. But there's a more serious issue with this piece of code. And to me, the problem with this code is that if authenticate failed, I cannot tell where in authenticate that failure happened. We just have the error. So if authenticate fails, we're going to pass it back up to the caller of authenticate request, and it's going to pass it up to its caller, and it's going to pass it up to its caller, and so on. And at the top of my program, we're probably going to print this error out to log it or something and find out what it is, and the result will be this. There's no information in the file or which line the error occurred on, and there's no stack trace in the call stack to tell me what happened. Now, Donovan and Kernighan's The Go programming language recommends that you add context to your error path using fumped errorf. But as we saw earlier, this pattern is incompatible with the use of Sentinel errors and type assertions because you convert the error value to a string, and you mix in that string with some other stuff, and then you convert it back into a new error using form_to_error_f. And so this breaks equality and destroys any context of that original error. It's now gone because it's just made into a string. So I'm going to talk a little bit about how I add context to errors. And to do that, I'm going to talk about a very simple package that I've been working on. So this package only has 5 public functions and a few types, and they really exist mainly as a place to hang the documentation. The first function is new, which, just like the errors package in the standard library, returns an error with the message that you provide. You print it out, that's what you get. The second function is wrap, which returns a new error wrapping the error that you passed in and a message. So if we print this one out, good old K&D style. And you're probably thinking at this point, congratulations, David. Like, what's the point? This is exactly what we have now. So let's look at this first example again, but just pay attention to the formatting verb. It's the same called errors.new, except this time when we print the error, we're going to use %+ v. We get a full stack trace. And this works because each time you call one of the functions in the error package, the error returned, as well as containing the message and the other information, records the stack trace where it was created. And now these error values also implement the form.formatter interface, which lets them know how to print themselves. And so the choice of how you want to present that error is controlled at the time you print it using different formatting verbs. Now we've got a few other convenience methods in there, like we have the classic errors.errorf if you want to do a formatted error, and wrapf, which is similar in function. And now, because we've introduced the concept of wrapping errors, we need to talk about the reverse, how to undo this process, how to unwrap them. And this is the domain of errors.cause. Cause takes an error, any error, and undoes this wrapping process, possibly recursively, to retrieve the original error, the underlying error. Now, in operation, whenever you have a piece of code that needs to check an error matches a specific value or type, you should first unwrap it using the cause function. So that's really the only change from the previous example we saw. And lastly, I want to mention that you should only handle errors once. Handling an error means inspecting the error and making a single decision. Now, if you make less than one decision, you're obviously ignoring the error, and you can see this here. The error from w.write is simply being discarded. Everyone in this room knows that this is not great. But making more than one decision in response to a single error, I think, is also bad. In this example, if an error occurs during write, a line will be written to the log file with the file and the line close to where the error occurred. Like it's a few lines off, but it's pretty close. You'll be able to find it. And the error is also returned to the caller, who might also log it and return it to its caller, who will log it and return it, and log it and return it all the way up to the top of the program. And so the result of this is that you get a stack of duplicate lines in your log file, each telling you the same thing. And at the top of the program, all you get is the original error without any context. The errors package gives you the ability to add context to an error value in a way that's understandable by both humans, and when you print them out, and machines if you use errors.cause to unwrap it to recover the original error. In this example, if there is an error in the call to w.write, we're going to wrap it with the annotation write failed. Again, the errors package makes this easy because as these functions are defined, if you ever pass in nil, they just unconditionally return nil. So you don't need to add that extra if error not equal nil stuff. So this helps reduce the verbosity of having to check if the error was not nil, just so that you can annotate it. So to summarize, errors are part of your package's public API. Treat them with as much care as you would treat any other part of your public API. For maximum flexibility, I recommend that you treat all errors as opaque. And when you're in a situation that you can't do that, assert the error for its behaviour, not its type. Minimize the number of Sentinel error values in your program, and avoid overloading the error values to convey something which is not actually an error. Like, don't use this as a side channel. And if you interact from a package outside your repository, outside code that you've written, convert any errors that you receive to opaque errors by wrapping them, because this will establish a stack trace that you can use to follow when you need to debug your program. And I think this advice also applies to interacting with the standard library. And lastly, use errors.cause to recover the underlying error if you need to inspect it. And in conclusion, proverbs are not rules and they're not laws. They're just stories. Proverbs are a great way of encapsulating information and capturing the essence of a lesson or teaching a moral. But they can equally be bewildering to newcomers who haven't been steeped in the law, who haven't learnt the meaning behind the proverb. And I want to leave you to consider the meaning behind the other Go proverbs. Thank you very much.